Hey there, math hoppers. In this video, we are going to learn all about slope and linearity. So what does it mean to be linear? Well, for a relationship to be linear, there must be a constant rate of change. You must either rise or fall by the same amount each time. Let's look at this table. In this table, our x values are increasing by 1 each time. And what's happening to our y values? As our x values increase by 1, we go from -8 to -5. That is an increase of 3. -5 to -2, an increase of 3. -2 to 1, an increase of 3. And from 1 to 4, another increase of 3. So we have a constant rate of change that is +3, and it must be present in every single instance. Otherwise, it is not a linear relationship. Okay, so if we were to graph these, guess what? We call them linear relationships. When we graph them, they look like a straight line. If your graph is not a straight line, it is not a linear relationship, and there is not a constant rate of change. For this line, we look and we see that we go to the right 1, up 1 unit. To the right 1 unit, up 1 unit. The constant rate of change for this graph is +1. What about some real-life examples of linear relationships? Well, suppose you babysit, and each week you take your babysitting money and you take 25 of it and you put it aside in a shoebox. Well, the rate at which you're saving money would be a linear relationship. That constant rate of change would be 25. Suppose a website gains 50 new subscribers each month. It's very unlikely it gains exactly 52 new subscribers each month, but if it did, that would be a linear relationship, constant rate of change of 52. The distance traveled over time, if you run 4 miles per hour and you never slow down and you never stop and you never speed up, again, unlikely, but if this were the case, it would be a linear relationship with a constant rate of change of 4. Lastly, the water dripping. You've seen this in textbooks and classrooms for sure. If you collect water in a bucket from a leak and it leaks at a rate of 2 milliliters per second, that would be a linear relationship where the constant rate of change is +2. So we keep saying constant rate of change. Guess what? That's just slope. The big scary word that freaks everybody out, slope, is simply the constant rate of change we have been talking about. Slope can be thought of as the steepness of a graph. Remember, it's the rate at which it either rises or falls. Slope can be negative. Visually, we can think of it as rise over run. Think about steepness as how high you've climbed or how much you've fallen versus how much you've traveled horizontally. Okay? Mathematically, this is just another unit rate of change. You guys have been learning unit rate of change since about 7th grade. This is just another one. It is literally the unit rate of change with regards to change in y over change in x. So if you look at this graph right here, between this point and this point, we have gone vertically 1, 2, 3, 4 units. However, this is not a steepness of 4. A steepness of 4 would mean you go from this point right up here up 4, right? You would be way up there. You'd be much steeper. This has a vertical change of 4, a horizontal change of 1, 2, 3, 4, 5, 6. So this slope would be 4 over 6 or 2/3. And it would be positive because look, we are going up as the x values increase, right? Okay, so we're going to get more into this later. Let's look at some classifications of slope. We're going to look at 3 of them right now. You can have a positive slope where as your x values increase, your y values also increase. This line rises as you travel to the right. You can have a negative slope where the opposite happens. The graph is falling as you go to the right. As the x values increase, the y values decrease. And you can have a 0 slope where the y values remain constant. The y values remain here constant at 3 as x travels to the right. As x gets larger and larger and larger, y stays exactly the same. 0 slope roofs you might see in the southwest or somewhere where it doesn't rain are those flat roofs. A lot of times adobe homes have a flat roof. They're called a 0 slope roof. You would never see them somewhere with snow because the roof would cave in. But that's where the term comes from. They are literally called 0 slope roofs. And again, there's one more type of slope, and we will discuss that one a little bit later. Okay, let's really dig into calculating slope visually. We talked about it being change in y over change in x. We've also talked about it being rise over run. So now let's really look at that. We have 2 points here that we're going to use for this. We have 0, 0, the origin, and we have 5, 7. So if we want to calculate the slope of this line, we can use any 2 points. We're going to use 0, 0, and 5, 7. So for our change in y, how much y is changing? What is the rise in this graph? We can simply count. We can say 1, 2, 3, 4, 5, 6, 7, and that would give us a rise of positive 7. For our run, we can do the same thing. We travel 1, 2, 3, 4, 5 units to the right for a run of positive 5. Writing that as the ratio of rise over run, we get 7/5 as the slope. Not too bad. Let's look at one more. We're going to take this graph. If we want to find the slope from this graph, we're going to locate 2 points. I'm going to pick 0, 1 and 1, 3. They seem easy. They're not anything I have to estimate. And we are going to calculate the vertical change and the horizontal change. And we will write it as change in y over change in x. So looking at our vertical change first, as we travel from 0, 1 to 1, 3, we go up 2 units. Looking at our horizontal change, as we go from 0, 1 to 1, 3, we go to the right 1 unit. That gives us a vertical change of 2, horizontal change of 1. So our change in y over change in x is 2 over 1, or simply 2. And that's our slope. Okay, let's look at it arithmetically. Let's keep the graph there for visual, but let's really look into what are we going to do when we calculate slope. We're not going to graph every line we calculate the slope of. So let's start talking about how we can write change in y and change in x in a slightly different way. When we do change in y, okay, look at these 2 points. We have negative 3, 1 and 3, 5. So our y value goes from 1 to 5. Our x value goes from negative 3 to 3. We can write change in y over change in x as y2 minus y1 over x2 minus x1. And this is really where people check out. They see this and they think, that's it, I'm done, I'm out. But it's not too bad. We can think of this point as being x1, y1, or the first point, and this point as being x2, y2, or the second point, and we can simply say the change in y is 5 minus 1, the change in x is 3 minus negative 3. That's all we're doing. We're putting a mathematical rule for something we've been doing. Okay? So let's look at where y2 minus where y1 would exist. It would be that change in y, that vertical change. We could still find it by counting 1, 2, 3, 4, or we could subtract 5 minus 1. Let's look at our horizontal change. We could count it 1, 2, 3, 4, 5, 6, or we could subtract 3 minus a negative 3. Let's look at it arithmetically. 5 minus 1 over 3 minus negative 3. Remember, when we subtract a negative, we are adding a positive. We get 4/6 or 2/3. Now you might be thinking, what if I didn't label this x1, y1? How did I know that this was my first point and this was my second point? Well, the good news is it does not matter which point you label x1, y1 and x2, y2. Don't believe me? Let's look at it. Let's switch it up. Let's make it so that 3, 5 is x1, y1, and negative 3, 1 is x2, y2. So now our change in y is going to be what? This is x2 or y2, so we're going to say 1 minus 5. This is x2, so we're going to say negative 3 minus 3. It will not matter as long as we are consistent. 1 minus 5 over negative 3 minus 3 is negative 4 over negative 6, and negative divided by negative is positive, so we get positive 4/6, which is still positive 2/3. Not too bad. Let's look at another example. 2, 4 and 4, negative 4. We want to find the slope through these 2 points. What is the rate of change for the line that passes through these 2 points? We will put the scary slope formula up there, and we will put the 2 points here. Okay, so I'm going to call this x1, y1. and I'm going to call this x2, y2. And let's see how it works out. Let's find our change in y. So y2 minus y1 is negative 4 minus 4, gives us negative 8. Let's look at our horizontal change. x2 minus x1 is 4 minus 2. Notice our arrows are moving in the same direction. It does not matter which point you label as the first or the second. It matters that you are consistent. If you are subtracting in this direction for y, you must also subtract in this direction for x. Let's look at what this looks like. Negative 4 minus 4 over 4 minus 2 is negative 8 over 2, or negative 4. Okay, I said it did not matter which point we labeled x1, y1 and x2, y2. So let's flip it. Let's do this again, but let's label this x1, y1 and this x2, y2. So change in y now is y2 minus y1 is 4 minus negative 4. And x2 minus x1 is now 2 minus 4. So 4 minus negative 4 over 2 minus 4 is positive 8 over negative 2, which still gives us negative 4. Remember, a positive divided by a negative, negative. Negative divided by a positive, still negative. All right, let's do another one. The slope through the points negative 3, 1 and 7, negative 9. We'll put the formula up there. We'll list the points out there. We will first say negative 3, 1 is x1, y1, and 7, negative 9 is x2, y2. So let's look at that y2 minus y1 and get negative 9 minus 1. Let's look at our horizontal change. You get 7 minus negative 3. Remember, negative 9 minus 1 is negative 10. 7 minus negative 3 is positive 10. We end up with a slope of negative 1. We're going to flip it one more time. Looking at the 2 points, reversing which way I subtract. So switching which point is the first and the second. Our change in y this time is 1 minus negative 9. Our change in x this time is negative 3 minus 7. Looking at the math, it's 1 minus negative 9 is positive 10 over negative 10. We still get negative 1. Do we need to do one more? Well, let's change this one up. Let's look at the points 5, 3 and negative 6, 3. Let's put the slope formula up there. You might already be thinking something's weird with these points, but let's look at it anyway. Let's look at our change in y. Change in y, there is no change in y. We go from 3 to 3. 3 minus 3 is 0. Anytime both y coordinates are the same, your slope will be 0. Think about it. 0 divided by anything is 0. So, just for fun, I suppose, let's look at the rest of this. Let's look at the change in x. Negative 6 minus 5, we get negative 3 minus 3 over negative 6 minus 5. We get 0 over negative 11. Remember, 0 divided by anything is simply 0. If your y coordinates are the same, you have a 0 slope. Well, if we have a 0 slope when our y coordinates are the same, what happens when our x coordinates are the same? Well, you'll get something like this. You get what we call an undefined slope. So let's look at 2 points on this graph. Any 2 points. I'm going to pick 5, 5 and 5, negative 2. All right, notice that no matter which points I picked, all of the x coordinates are the same. They're on this vertical line of x equals 5, right? This would be 5, 2, this would be 5, 1, this would be 5, 0. The x coordinate is going to be 5 no matter which point I pick. So, when we use the slope formula, something really bad is going to happen. This means there will be a 0 in the denominator. Think about this. If we have change in y over change in x, we are going to have 5 minus negative 2 over 5 minus 5. And we cannot have 7 divided by 0. We cannot have 0 in the denominator. Remember, if I have $7, I cannot equally put $7 into equal groups of 0. I just can't do it. And for a visual reminder, remember that it is okay to divide 0 by a number, right? Okay to divide 0 by a number, but it is not okay. No, you cannot divide a number by 0. All right, that was a lot. Hopefully you got this. If you're working on some homework or you're doing the quiz after this and you find yourself having troubles, You should be subscribed to our YouTube channel. Submit any and all of your problems there. You'll email them, we'll make you a custom video, and we will clear up any fogginess that is still there. Until next time, Math Hoppers, have a good one.